we're going to still be talking about our inverse operations of that squaring a number and finding the square root. Those undo each other. And finding cubes of numbers and their inverse operation, the cube root, they undo each other. We're still going to be classifying our numbers today. We're going to start classifying them as the rational and irrational. You might have heard me use that word, irrational, for some of our answers when we were talking the other day. And we're going to be evaluating ones that are not our perfect ones. So when we take a look here, it says the number 5 and negative 5 are both square roots of 25 because when you square them, they each give you 25. Every positive number has two roots. It has a positive and a negative. 0 has one root. The square root of 0 is 0. Okay, so if you want to even write that, the square root of 0 equals 0. So this is our positive. And notice that the negative is out here. Negative square root of 25. It's not underneath. If it's underneath, we have another special kind of number, which you won't deal with till Algebra 2, and it's called an imaginary number. Did you know there was such a thing? No. There are. There's imaginary numbers. Just like some of you might have had imaginary friends. There's imaginary numbers, right? So we don't have to deal with that this year. Our negatives are going to be out in front of the square root, okay? This is called the radical symbol, the symbol, and the number that's underneath is called the radicand. So kind of just some vocabulary. So, on that next one down, square root of 49 should be 7. If you know your math facts, this is going to be easy, right? Fill these in. Right in your notes. Square root of 36 should be 6. The negative square root of 100 is negative 10. Oh, we get to fractions. I want to use my calculator. Don't. Notice at the top of this unit, it said no calculator. So this is what you want to think. What is the square root of 4? 2. What is the square root of 49? Think of it as 2 separate. 7. My answer is 2 sevens. Okay, make it better. Do not think of it as the fraction 1/9. We can pull that apart. There's a property for that. We don't have to worry too much about the property. But it says anytime you have a square root, if you have square root of 1 divided by square root of 9, you can write it this way or you can write it this way. Okay? Square root of 1 is 1. Square root of 9 is 3. Okay? You will have fractional answers. Fractions are okay, even if you don't like them. Okay? Top of the next page. This part here, if you do happen to have a highlighter or something you want to mark, this right here is what you will be asked to write on the test. You will be asked to do something like this. It's going to say, give me the approximate answer for square root of 95 to the nearest 10th, and you will not have your calculator. So this right here is what we will ask you to write, okay? Now, the reason that I was kind of picky on, hey, do you know those perfect squares and cubes, is because of, if I ask you for the square root of 95, what two perfect squares is it between? 95. What two perfect squares is 95 between? It's between 100 and what comes before it? 9 times 9, which is 81. So, this part right here, because when we do this, this is what we're going to do. We're going to put the numbers. We notice, first thing, that 95. I'm going to give you 2 number lines in your homework. How you will start this is you'll start with this first number down here at 9, and then you'll put 10. You won't have to put all these dots in between, but you'll put 9 to 10. And then you'll put 9.5. Now, we know above 9 that the square root of 9 is 81. And we know that above 10, the square root of 100 is 10. We aren't going to put anything right here right now. But if we are thinking of the numbers, so then this is what we'll do. We'll write this out. We'll say the square root of 81 is 9. Square root of 100 is 10. So 95 must be between 9 and 10. That's what I make my number line. You're going to draw 2 number lines. One will have square root of 81, one will have square root of 100. You're going to mark the location of square root 95. Well, we don't know exactly where it is, but if you think of the number 95, if this is 9 and a half, and this is going from 81 to 100, what is the number halfway between 81 and 100? How could I find this exact number right here? I take 81 plus 100, right? Do you agree? 181 and divide it by 2. 2 goes into 18 how many times? 9. And then 2 can't go into that 1, so it's going to be like 90.5. Do you agree? So this number right here is 90.5. I'm going to find that on mine, okay? Then I noticed, well, 95 is bigger than that, so it's halfway between 90 and 100, so now I'm going to go, oh, I think 95 is here. And then I'm going to approximate that if this is 9.5, this might be 9.75. I might even take 9.7 from you, right? I would take that for an answer of approximating it, okay? So when we look at this, it actually comes out square root of 97 is 9.7 because it's 3/4 of the way between. So let's do this next one. 23 is between what two perfect squares? It's between 16 and 25. So we're going to put up here the square root of 16. Down below it, we're going to put the square root of 16 is 4. Way over here, we're going to put square root of 25. Do this now with me. Write this down. 5. In the middle, I know we got a minute, 4 1/2. We need to find halfway between 16 and 25. You're finding the average, right? 16 plus 25 gives us 41. Divided by 2 gives us 20.5. Let's go eat. Sorry. 4 1/2, 20.5. Where would you say 23 has to be up here? Between 16 and 20.5, 20.5 and 25. Between 20 and 25, right? We'd say about maybe a little over halfway, right? Because this would be 20, right? So if this is like 20 is right here, then you got to have 21, 22, 23, 24, and then you have 25, right? So those should be equally spaced out. So 24, 23, square root 23, right? About here. Does that make sense to you guys? And what do we think approximately? We might say between 4 1/2 and 5. Where would you like to approximate where you think that is? Okay, write it down, and I will show you. Where do we think this should be? Like what number? Okay. Does 4.8 maybe make sense to you? Okay. Could you have had 4.75? I'd take 4.75 if you wanted to go to the hundredth place, right? I'd maybe even take 4.7, but I think 4.8 is probably a little better. Okay. So you're thinking 6, 7, 8, right? 4.9. So does that make sense what you're going to approximate then? Let's try that next one. So 72 is between what two perfect squares as we start taking a look? So between, if we are looking at, what do we think as you look at that? Madeline, what do you think? What two perfect squares? 72 is in between. We're thinking just numbers, yes, but I want you to think back to that list of numbers at the beginning, the perfect squares. Okay, so when you think of this list, look back in your notes the page before. What two perfect squares is 72 in between? The top one is, if we were thinking, what would you say? 64 and 64, so we're going to go square root of 64, right? And up here, we're going to have the square root of 81. Put below what integers those are. We have 9 and we have 8, right? So we know this has to be 8 point something, right? Put your number line, put the two numbers that I have up there. Square root of 64, right? Okay. We're going to continue with that, right? If I'm continuing with that, Nikita, did I say it right? Okay, you ready? Halfway, 8 and a half, right? How am I going to find the number up here that I'm thinking is underneath that square root? 64 plus 81. If we add those two, what do we get? Does that make sense to everyone? 145? Okay. 8. I need to find half of that, right? Dividing it by 2. What do I get? 72.5. Okay, does that make sense to everyone? 2 goes into 14 7 times, 2 goes into 5 2 times, and then since it's 5, it's 2 and a half. 72 and a half. All right, so, oh my gosh, we almost have our answer, right? We've got 72 and a half. 72 is just going to be a little before that, right? So I'd like you to estimate where you don't even have to try and move it in between the two. We know it has to be between 8 and 8.5. So please write down what you think your answer is and check with your shoulder partner. Could we go with 8.5? I mean, this is 72.5. We think that it's going to be like really close to that. I would take 8.4 also. I'd take either one of those answers. Okay? But when you do this, I will definitely need to see this, right? I'll need to see this. I'll probably want to see how you came up with this number. And if you have to do the long division, like you go, oh, I have to divide it like by, if you want to write that out, I don't care. But there's no calculators on this part, right? So as you are looking at this, okay? So you're going to see like about in your homework tonight, I think there's like maybe 3 or 4 like this that you have to do, okay? We're almost done with notes for today. We just have a little bit left. So if you are going to read for us, please, Alex, would you read for us? And it's easier to read probably from yours because mine kind of like overlaps and it won't let me change it. Yep, the number 3.
The number 3 is a cube root of 27 and cube 3. You get 27. A cube root has an index of 3. A square root has an index of 2, but we usually don't write it.
So if we want to check on your calculators, we can check this also. We're not going to use them right now. We'll do this coming up. But if we are thinking about something, a lot of times if it's a square root of 4, this index is 2. They just don't ever write it in, okay? When it's a square root, there's understood that this is a 2 here. We just usually don't write it. We just put the square root, meaning it's the second root, okay? But any other one, they will always put a number. So the cube root of 64, and always go small because even if you think of dividing this by 2, it's 8, has to be less than that because it's a cube, or dividing it in, taking like what number multiplies to give you 64, and you think 8 has to be less than that. And again, if there's a negative out in front, the negative cube root of that number is going to be negative. This is our index. It tells you how many numbers you're multiplying together to get 8, right? So when you think of this, this is trying to say, okay, there has to be 3 things that multiply that equal 8. Okay, they all have to be the same thing, right? When I multiply these, they have to be the same number. So that's why the cube root of 8 is 2. So it ends in a 5, right? What do you think the cube root of 125 is going to be? We would think it's probably 5. Oh, we love ones, and I'll have some people really struggle with their ones, right? And for some reason, they just want to always think that, like, maybe this should be 3 or something else. The cube root of 1, what number times itself 3 times gives you 1? 1, and in this case, it's going to be negative. Now, this cube root of 27, you're going to do in the same way as we did those fractional ones. So 127, you're going to think, oh, what is the cube root of 1 divided by the cube root of 27? And the cube root of 1 is 1, and the cube root of 27 is 3. Yeah, I know. 9 times. So sometimes people think, oh, do I divide 27 by 3? And that's not what you're doing. This is not 27 divided by 3. It's saying what multiplies 3 times to get 27. Okay? All right. So, top that next page. Or next page down in your notes, I guess, for you. It's the next page down. Last page for today before we look at your homework. It says when you look at the 2 tables to the left, they show you squaring a number and taking the square root. These are inverses. That's the word you want to fill in that blank. Okay? Inverses. This means operations that undo each other. Most common ones that you guys know are addition undoes subtraction, subtraction undoes addition, multiplication with division, right? This comes in if you think about how we found those areas of our squares. What this means right here, this square root of 3 squared, if you think when we were doing our areas, this is how we wrote it. We said, oh, one side was square root 3, and another side was square root 3, right? And that actually gave us this. And these 2 things will always undo each other, so it just gives us 3. So the square root and the exponent will undo each other, and that is a beautiful, beautiful thing. Because if I say the side length is 17.3, so well, what's the area of that square? Oh, I'm going to take 17.3, that's the side length, right? And I'm going to square it. That means these 2 undo themselves, and my answer is that the area is just going to be 17.3. It's whatever underneath there. So it could be a nice number, it could be an ugly number, and you don't want to use your calculator for that. You just want to know that these 2 things undo each other, okay? So, I'm going to have you turn to your homework, and I'm